Good morning students. Welcome to Tata Chem DAV Public School Mithapur online classes. Myself Kavita, your maths teacher for class 6. We are going to continue chapter 2, factors and multiples. In this chapter, our topics are find the HCF by factor method, find the HCF by prime factorization method, and find the HCF by continued division method. Our first topic is find the HCF of 12, 30 and 54 by factor method. In this method, first we find the factors of 12, 30 and 54. Let's start with 12. To find the factors of 12, first we write 12 as a product of two numbers. We have to think of all the possible combination of 12. If we list in factors, always start with 1 and number itself. So 12 can be written as 1 multiplied by 12 is equal to 12. Is 12 completely divisible by 2? Yes, the product can be written as 2 multiplied by 6 is equal to 12. Take the next number 3. Is 12 completely divisible by 3? Yes, the product can be written as 3 multiplied by 4 is equal to 12. Then we move on 4, which is already covered here. When we know that we had covered all possible products of two numbers, so stop here. So the factors of 12 is equal to 1, 2, 3, 4, 6 and 12. Then we find all the factors of 30. We have to think all the possible combination of 30. First we write 30 as a product of two numbers. If you list in factors, always start with 1 and number itself. So 30 can be written as 1 multiplied by 30 is equal to 30. Is 30 completely divisible by 2? Yes, the product can be written as 2 multiplied by 15 is equal to 30. Is 30 completely divisible by 3? Yes, the product can be written as 3 multiplied by 10 is equal to 30. Is 30 completely divisible by 4? No, so leave them. Is 30 completely divisible by 5? Yes, the product can be written as 5 multiplied by 6 is equal to 30. Then we move on 6, which is already covered here. When we know that we had covered all possible products of two numbers, so stop here. So the factors of 30 is equal to 1, 2, 3, 5, 6, 10, 15 and 30. Then we find all the factors of 54. First we write 54 as a product of two numbers. So 54 can be written as 1 multiplied by 54 is equal to 54. Is 54 completely divisible by 2? Yes, the product can be written as 2 multiplied by 27 is equal to 54. Is 54 completely divisible by 3? Yes, the product can be written as 3 multiplied by 18 is equal to 54. Is 54 completely divisible by 4? No, so leave them. Is 54 completely divisible by 5? No, so leave them. Is 54 completely divisible by 6? Yes, the product can be written as 6 multiplied by 9 is equal to 54. Is 54 completely divisible by 7? No, so leave them. Is 54 completely divisible by 8? No, so leave them. Then we move on 9, which is already covered here. When we know that we had covered all possible products of two numbers, so stop here. So the factor of 54 is equal to 1, 2, 3, 6, 9, 18, 27 and 54. Then we find out the common factors. So the common factors of 12, 30 and 54 is equal to 1, 2, 3 and 6. Then we find out the HCF. So the highest common factor of 12, 30 and 54 is equal to 6. Hope you understand how we will find out the HCF by factor method. In this method, first we find prime factors of 24, 16 and 36 by division method. Let's start with 24. 24 is an even number, so we start our prime factorization by smallest prime number 2. So write 2 to the left of 24 and divide. We get 12. So write 12 below 24. Again 12 is an even number, so we divide 12 by the smallest prime number 2. So write 2 to the left of 12 and divide. We get 6. So write 6 below the 12. Again, 6 is an even number, so we divide 6 by the smallest prime number 2. So write 2 to the left of 6 and divide. We get 3. So write 3 below the 6. But 3 is an odd number, so we divide 3 by the next smallest odd prime number 3. So write 3 to the left of 3 and divide. We get 1. If we get 1, this means we need to stop here. So the prime factorization of 24 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3. Let's find the prime factors of 16. 16 is an even number. So we start our prime factorization by the smallest prime number 2. So write 2 to the left of 16 and divide. We get 8. So write 8 below the 16. Again, 8 is an even number, so we divide 8 by the smallest prime number 2. So write 2 to the left of 8 and divide. We get 4. So write 4 below the 8. Again, 4 is an even number, so we divide 4 by the smallest prime number 2. So write 2 to the left of 4 and divide. We get 2. Again, 2 is an even number, so we divide 2 by the smallest prime number 2. Write 2 to the left of 2 and divide. We get 1. If we get 1, means we need to stop here. So the prime factorization of 16 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2. Let's find the prime factorization of 36. 36 is an even number, so we start our prime factorization by the smallest prime number 2. So write 2 to the left of 36 and divide. We get 18. So write 18 below the 36. Again, 18 is an even number, so we divide 18 by the smallest prime number 2. So write 2 to the left of 18 and divide. We get 9. So write 9 below the 18. But 9 is an odd number, so we divide 9 by the next odd prime number 3. So write 3 to the left of 9 and divide. We get 3. Write 3 below the 9. Again, 3 is an odd prime number, so we divide 3 by 3. We get 1. If we get 1, means we need to stop here. So the prime factorization of 36 is 2 multiplied by 2 multiplied by 3 multiplied by 3. Then we find the common factors. So common factors of 24, 16 and 36 is equal to 2 multiplied by 2. Then we find the highest common factor. So the highest common factor of 24, 16 and 36 is equal to 4. Hope you understand. Find the HCF by prime factorization method. Our next topic is find the HCF of 345 and 506 by continued division method. In this method, divide the bigger number 506 by the smaller number 345. See the table. 690 is bigger than 506, so we take 345. So write 345 below the 506. How many times? 1 times. So write 1 as the quotient. Subtract 345 from 506. We get 161 as the remainder. Now we need to take this remainder as a divisor and divide this number by the previous divisor 345. So divide 345 by 161. See the table. 483 is bigger than 345. So we will take 322. How many times? Count. 2 times. So write 2 as the quotient. Now subtract 322 from 345. We get 23 as the remainder. Again, now we need to take this remainder as the divisor and divide this number by the previous divisor 161. See the table. 23 sevens are 161. So write 7 as the quotient and write 161 below 161 and subtract. We get 0. If the remainder is equal to 0, this means we need to stop here. So the divisor of the last step is the HCF of 345 and 506. Some of you might be thinking, if we know prime factorization method, so why to learn long division method? If we use prime factorization method to find the SCF of large numbers, we will get lots of prime factors and it will be very difficult for you. But if you use continued division method, then you can find the SCF of large numbers very easily. Let's solve one more question. Find the SCF of 1212, 6868 and 1111 by continued division method. We know that we can only divide one number by another number. So we can use only two numbers. So how do we find the SCF of three numbers by continued division method? It is possible to do that. Let us see how to do it. First take any two numbers. You can take any two out of the three numbers. So suppose I take two numbers in ascending order, 1111 and 1212, and find their SCF. For a time being, forget about 6868 and find the SCF of 1111 and 1212 by continued division method, as we have done earlier. So divide the bigger number 1212 by the smaller number 1111. How many times 1111 go into 1212? One time. So write 1111 below 1212 and subtract. We get the remainder 101. Now we need to take this remainder as the divisor and divide this number by the previous number 1111. First we take 3-digit number 111 because 111 is bigger than 101 and divide. How many times 101 go into 111? One time. So write 101 below 111 and subtract. We get the remainder 10. Now pull down 1. We have 101. How many times 101 go into 101? One time. And subtract. We get the remainder 0. If the remainder is equal to 0, this means the divisor of the last step is the SCF of 1111 and 1212. So the SCF of 1111 and 1212 is 101. See, we found the SCF of just two numbers, 1111 and 1212. But what about 6868? Now take 6868 and 101, which was the SCF of 1111 and 1212. So we find the SCF of 101 and 6868. Divide 6868 by 101. First we take 3-digit number because 686 is bigger than 101 and divide. How many times does 101 go into 686? 6 times because 101 6 ja 606. So write 606 below 686 and subtract. We get the remainder 80. Now pull down 8. We have 808. How many times does 101 go into 808? 8 times because 101 8 ja 808. So write 808 below 808 and subtract. We get the remainder 0. If the remainder is equal to 0, means the divisor of the last step is the SCF of 1111, 1212 and 6868. So the SCF of 1111, 1212 and 6868 is 101. Let's solve one more example. Find the SCF of 144, 384 and 120 by continued division method. First we arrange the number in ascending order, 120, 144 and 384. Then we find out SCF of 120 and 144 by continued division method. Divide the bigger number 144 by the smaller number 120. See the table. 240 is bigger than 144. So we take 120. How many times? 1 time. So write 1 as the quotient. Subtract 120 from 144. We get 24 as the remainder. Now we need to take this remainder as the divisor and divide this number by the previous divisor 120. So divide 120 by 24. See the table. 24 5s are 120. So write 5 as the quotient. Now subtract 120 minus 120. We get 0. If remainder is equal to 0, means the divisor of the last step is the HCF of 120 and 144. Therefore, the HCF of 120 and 144 is 24. But what we need to find is the HCF of 120, 144 and 384. We found the HCF of just two numbers, 120 and 144. But what about 384? So, now you will know, pay attention. Take 384 and 24, which was the HCF of 120 and 144. Now we need to find the HCF of 24 and 384. That is, we need to divide larger number by a smaller number. So we divide 384 by 24. First we take 2-digit 38 because 38 is bigger than 24 and divide. How many times does 24 go into 38? 1 times. So write 24 below the 38 and subtract. We get the remainder 14. Now pull down 4. We have 144. How many times does 24 go into 144? Yes, 6 times. So write 144 and subtract. Now the remainder is equal to 0. So what will be the HCF? The divisor of the last step. So which is the divisor of last step? Yes, 24. Hence the HCF of 120, 144 and 384 is equal to 24. Hope you understood how we will find out the HCF by factor method, prime factorization method and continuing division method. So students, complete lesson 2, worksheet 5, question 1, 2 and 3 once in Maths CW and rep book also. Thank you. Have a beautiful day.